Let's do the chapter 2. Name of the chapter is Acid, Bases and Salt. Now let's do the quick revision of chapter 2 and the important topics covered in this chapter. First of all, we should know about the physical properties of the acids and the bases. Acid and the bases, you can make the table and differentiate on the basis of their properties. So first, acids are sour in taste but bases are bitter in taste and having soapy touch. And acid turns blue litmus paper into red, but bases turn red litmus into blue. Acids can be identified on the basis of hydrogen ions. If HCl, for example HCl, it contains hydrogen ions, and in this case if I write NaOH, sodium hydroxide, then it contains hydroxide ion OH. If acids, the identification of the acid is presence of hydrogen ions or hydronium ions H3O positive in aqueous form. But when the substances release OH negative ions in the aqueous solution, that are called bases. Acids, the physical property of the acids are because they conduct electricity in the aqueous solution, but bases conduct electricity they also conduct electricity in the aqueous solution because they contain both hydrogen ions and OH negative ions. But it depends upon the strength of the ions, which ions are more. If H ions are more, then they are acids. If OH negative ions are more, then they are called bases. Example of the acid, you can memorize these acid and write their formulas. First one is sulfuric acids and its chemical formula is H2SO4, hydrochloric acid HCl, acetic acid CH3COH, ethanoic acid, nitric acid HNO3. And examples of the bases, sodium hydroxide, it may be called, general name is called caustic soda and its chemical formula is NaOH. Calcium hydroxide COH whole twice, potassium hydroxide, that is also called caustic potash, and KOH is its chemical formula. And one line is written below this, that alkalis are bases soluble in water. It means those bases which are soluble in the water are called alkalis, but all alkalis are not bases. You have to keep in mind. Now there are some naturally occurring acids around us. We will see vinegar. When you eat chow mein, then vinegar is present in it, and vinegar contain acid. Which acid is present? Acetic acid. When you eat curd, it is bitter in taste or it is sour in taste. You can identify, I think curd is sour in taste. It produces acid and it is lactic acid. Tamarind is also contain tartaric acid. Spinach, oxalic acid. So these are the few naturally occurring acids in our surroundings. Now the next important topic is how to prepare the sodium hydroxide, that is a strong base. How can we prepare it? So NaOH is prepared or obtained by electrolytic decomposition of the solution of sodium chloride. And what is the sodium? This whole process is called chloralkali process. Because why it is called chloralkali process? Because the products are chlorine, that is written Cl2, alkali, NaOH, and hydrogen gas is also produced. So it is called chloralkali process. Because when the aqueous solution of the NaCl is decomposes into alkali, sodium hydroxide, which is soluble in the water, chlorine and hydrogen. Chlorine gathered on the anode and the hydrogen gathered on the cathode in the electrolytic decomposition of the solution. Now, what are the acid-base indicators? As indicators are the substances or the chemicals which help us to identify whether the given substance are acids or bases. And there are the two types of the indicators. One is natural, other is artificial or human made. Natural indicators are those indicators just like litmus, which is obtained from the lichen plant, red cabbage leaf extract, turmeric. And smell, color, what are the changes you can see in the natural indicators? The color may be changed in the acidic medium, and red litmus, it converted into red, so it is acidic. If it is converted into blue, it is called basic. And red cabbage leaf extract becomes red in the acidic solution and green in the basic solution. If it is green in the basic solution, so it is base, red in the acidic. Turmeric, there is no change in the acid, but when you see, then when you put or rub soap on the turmeric or the haldi, you can see, then it becomes reddish and brownish in color. So soap is basic in nature. Then intermary is an indicator which shows that soap is basic in nature. These are the natural indicators and which shows the presence of acids and base. Other is synthetic indicators. When you see synthetic indicators are present in our science laboratories, and there are the two main synthetic indicators are used in our laboratories. One in phenolphthalein and other is methyl orange. In the acidic medium, the colorless, it becomes colorless in the acidic medium, and phenolphthalein color changes into the basic, it becomes pink in color. Methyl orange color becomes red in the acidic medium and yellow in the basic medium. So these are the identification of the indicators, and they identify which substance is acidic or basic. Now the third type of indicator is olfactory indicators. Olfactory means which identify the smell or any relative smell in the acidic or basic medium, when the smell changes in the substances. So it produces or it identifies which substance is acidic or basic. Then onion is the olfactory indicator, vanilla essence is also, and clove oil. In the acidic medium, there is characteristic smell in the onion, and in the basic there is no smell. Vanilla essence retains smell in the acidic medium and no smell in the basic medium. Clove oil retains smell in the acidic medium and loses smell in the basic medium. Now, you have seen that we can identify the substances which is acidic or basic, but we cannot identify which one is strong acid and which one is weak acid or weak base or strong base. Now there is one pH scale which always measure the strength of the H ions or OH negative ion in the aqueous solution, and range of pH scale is 0 to 14. When we see this scale 0 to 14, the mid term is 7. Below this, the medium is acidic, above this it is basic, and the 7 shows pH value of any substance which is 7, that is called the neutral substance. pH value less than 7 shows acidic substance, pH value greater than 7 shows basic substance. And on the basis of their strength, on the basis of their pH value, we can identify which one is strong and which one is weak. Now normally in our life, there is an importance of pH in everyday life. For example, first example is pH in our digestive system. Everybody knows that our stomach produces excessive acid and it causes indigestion. In order to cure indigestion, we take mild base like baking soda, milk of magnesia, and most popular is ENO. When you are suffering from the pain in stomach, then you use to drink ENO solution, and these ENO may be in the form of baking soda or milk of magnesia. So they are called antacids, means which neutralize the effect of acid and give relief in our stomach. So there is a importance of pH in our everyday life. And second is pH changes as cause of tooth decay. Tooth decay starts when the pH of the mouth falls below 5.5. Its value is very important to remember. Below 5.5 shows the tooth decay, and how can we prevent it? The best way to prevent the tooth decay is to clean the mouth after eating or using basic toothpaste which can neutralize the acid inside the mouth. Next one is self-defense by the animals and plants through chemical warfare. You have also experienced that when the ant stick bite or some nettle stings inject in our skin, then they produce methanoic acid into a person's body, and its sting causes pain and irritation. So we mostly use baking soda as a remedy because it is a base and it neutralizes the injected acid in our body, and we feel relief in the pain. Next is pH in the soil. If the soil is more acidic or basic, then how can we treat it? If the soil is too acidic, then we can put materials like quicklime or slake lime into the soil so it can neutralize. If the soil is too alkaline, means basic in nature, then it can be reduced by adding decaying organic matter because they contain acids. So with the help of other thing we can neutralize and we can use, or pH plays an important role in our daily life. Now in chapter 2 there are few salts that we have to study, and these are very important salts in which we have to study it in detail. Now the salts, what are the salts? First of all, salts are the ionic compounds which are produced after neutralization between acid and base, and this reaction is called neutralization reactions. When the strong base and strong acid Combined together, they form salt and water. This reaction is called neutralization reaction. And potassium hydroxide, HCl, KCl, H2. These are the two examples of neutralization reactions. Now, first salt is baking soda. You have to remember the chemical name of baking soda, that is sodium hydrogen carbonate. Before remembering this, you have to write the formula, that is NaCO3. Na is sodium, H means hydrogen, and CO3 means carbonate. So sodium hydrogen carbonate, or in simple language you can say bicarbonate. This ion is called bicarbonate. So sodium bicarbonate can be the name of baking soda. Now its preparation, how it is prepared? By heating limestone. What is the formula of limestone? Calcium carbonate. Then it is converted into CaO plus CO2. Now its uses, when carbon dioxide is passed through the concentrated solution of sodium chloride, ammonia and carbon dioxide and water, then it forms baking soda plus ammonium chloride. And where it is used, what are the uses of baking soda? It is used in textile industry, in paper industry, as disinfectant in water. It can be used. So this is about the baking soda. And most of the time students confuse about the baking soda and baking powder. Baking soda is NaCO3. But what is the baking powder? It is the mixture of baking soda and mild edible acid like tartaric acid. So it is called baking powder. Baking powder is used in making pastries, cakes, etc. But baking soda is used in making chola, or it may be the rajma. For cooking these things, baking soda produce carbon dioxide and make it soft. But baking powder is the combination of baking soda and mild tartaric acid, or very weak acid can be used in it. Now the next salt is washing soda. Washing soda, the formula of the washing soda is Na2 sodium carbonate dot mean dot, after dot 10H2 is written here, and these 10H2 are called the water of crystallization. And this what is the name of washing soda, chemical name? That is sodium carbonate. It is here. And water of crystallization of any salt remain fixed according to their structure. And what is how it is prepared? When baking soda is heated, then it produces carbon dioxide, water and sodium carbonate. This carbon dioxide make the things very soft and fluffy, and this sodium carbonate is called washing soda. And when it is, this is anhydrous, means it doesn't contain water of crystals. Water crystals are not present here, but when water is added in sodium carbonate, it forms washing soda. That is the formula of washing soda. And where it is used in glass, soap and paper industries for softening of water as domestic cleaner. You have seen many cleaners at the home, so it is used there, washing soda. Now the next one is bleaching powder. Very, very important. Sometimes it is asked in the 1 mark question. What is bleaching powder? Bleaching powder, the formula of the bleaching powder is calcium oxychloride. Very, very important. Ca means calcium, O means oxy, Cl2 means chloride. So it is called calcium oxychloride. Chemical formula and chemical name. How it is prepared? This is calcium hydroxide. When chlorine gas is passed through it, it forms calcium oxychloride and water is also released. So on interaction with the water, bleaching powder release chlorine, which is responsible for bleaching action. So bleaching powder is called calcium oxychloride. Now the next salt is plaster of Paris. In short, we call it POP. Everybody here is heard about POP. It is used in our houses for making roofs, for making toys. So many things are prepared by the POP. So what is its formula? Calcium sulfate hemihydrate, half H2O. Chemical name is calcium sulfate hemihydrate. So how it is prepared? Gypsum. There is a one substance, gypsum, whose formula is calcium sulfate 2H2O. When we heat it, then it is converted into plaster of Paris and 1.5 molecule of water. Its water of crystallization is fixed. I have told you earlier, in the washing soda, in the bleaching powder, it is fixed. So plaster of Paris contain only half molecule of water, half water of crystallization, so it is called hemihydrate. And gypsum can be prepared again when we doctor always advised when somebody get plaster on their hand or their legs after breaking some bones, then to join the bones doctor always advised to avoid the plaster from water, because plaster of Paris when mixed with the water it forms gypsum and it is a hard substance which is not comfortable for the person. It got injury at that place due to this, so avoid water from the plaster of Paris. Now what is the water of crystallization? Water of crystallization is the fixed number of water molecules present in one formula unit of salt. For example, copper sulfate, this is the one formula which contain 5 water of crystallization. Calcium sulfate contain 2 H2O. Sodium carbonate, the washing soda, contain 10. Ferrous sulfate contains 7, and gypsum, or you have studied about calcium sulfate hemihydrate, that is plaster of Paris, contain half number of water molecules in one unit formula. So these are the this is called water of crystallization. Now on the basis of these topics we have some questions. Now discuss this question. What is the color of methyl ornate in the basic medium? Then you have done in the previous. Mention the 2 constituents of the baking powder, that is one baking soda, other is the mild tartaric acid. What is the chemical name of POP? That is the calcium sulfate hemihydrate. What happens when the water is added to it? Then it converted into gypsum. Write the balance reaction. You can also see previous. Define water of crystallizations. Then we have studied about it. Give 2 examples of the salt that are water of crystallization and their chemical formula. Then you can write plaster of Paris, gypsum, calcium, you can copper sulfate 5H2O, washing soda Na2CO3 10H2O. So this is about the chapter 2. These are the important questions. I hope you understand the concept of acid, base and the salt. Keep watching Super Vigyan. Thank you so much.